This week, we're on the other side of the Atlantic attending EuroBSDCon. For now, however, we've got an awesome interview with Peter Wim about the FreeBSD web cluster and the infrastructure. It's an inside look that you probably won't hear about anywhere else. We also got to a couple of your emails today, and we will be back next week with all of our usual goodies here on BSD Now, the place to be, SD. BSD Now, episode 56, Beastly Infrastructure, recorded September 17th, 2014. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
And you might have noticed we're recording this, the week before this is supposed to air? And yeah, that's because we're gone this week. We're actually on the other side of the Atlantic. So we're going to be out at EuroBSDCon right now and hopefully having a good time. Me and Alan hanging out and getting some good interviews, so you guys have all been warned.
Well, at this point, I'll be like just getting off the airplane, I think. I arrive at like 1 p.m. on Wednesday.
Yeah, I think, I come in at 4 p.m. Wednesday as well.
So you'll still be on an airplane.
Coming in from Paris, I think. Yeah. Oh, man, jet lagged and tired. But anyway, it'll be a fun conference. Looking forward to it. And if you're going to be there, we'll look forward to see you. But of course, we do have a little episode this week where we've got some stuff we're going to pre-record. We have an interview we'll be doing in a moment. But before we get to that, we want to mention, of course, the sponsor for the week, which is IX Systems, of course. And that URL, ixsystems.com/BSDNow. Let them know we sent you. Fill out the form, download their free guide on what to know before you purchase a server for open source. Some of the business case stuff you can use to talk to management and talk to those who make the decisions in your company on why you should use IX Systems for all your server and storage and various solution needs.
IX was also a big sponsor of EuroBSDCon, so thank you to them for that and making sure that conference can happen so all of us can enjoy it.
Definitely. So, of course, IX Systems builds everything from small FreeNAS minis you can throw under your desk to the massive systems we've demoed in the past and shown off pictures and drooled over.
It's like 800 terabytes of storage or 80 cores or 24 10 gigabit NICs or whatever it is. Whatever you're trying to stuff into a box, they can do that. And that's, their free pre-purchase consultation isn't just a bullet point on the list of reasons you should use them. It's, talking to people that actually know about BSD and Linux and open source and about the hardware and actually mating those two together just right.
Well, how many vendors do you know that the build servers actually have committers on staff?
Exactly.
Writing these open source programs and stuff. I mean, just having that wealth of knowledge and experience all under one roof is a big deal. So definitely, if you need a server for anything or you need some kind of hardware solution, it's time to get in touch with IX Systems. And please let them know we sent you. We would appreciate that. Cool. Well, we'll be back in just a moment with our interview with Peter Wim for the week. Joined now by Peter Wim, FreeBSD developer, web cluster, infrastructure. So we're glad to have you on the show today, Peter.
Oh my, it's been a long time coming, I think.
Yes. I don't know how you ducked us for so long, and we didn't get you earlier, but we have you now.
That's the important thing,
right? So first up, the question we ask everyone: how did you first get involved with BSD? What led you to this point?
Oh boy. It's all the fault of a fellow by the name of Julian Elisha. He was working for a company called TRW Financial Systems in Oakland, I think it was. And at the local Unix users group in Perth, Western Australia, he said, "Hey, I've got an old machine that I need somebody to take care of while I'm overseas." And that was running FreeBSD 2.0, and it had full source code and had the biggest hard drive I'd ever seen in my entire life, and the rest is history. So source code, it had all of the archives of all of the early days of the BSD stuff. It was once ref.tfs.com, in case anyone remembers the name. So it was what became Freefall before it was Freefall.
Oh,
Okay, cool.
cool. So what do you currently do for the FreeBSD project? What are your hats or jobs?
So, oh boy. So in between a control freak, so most people sort of know of me as a developer. I've been FreeBSD committer for almost 19 years now. 19 years this no 19 years now. Been on FreeBSD core on and off for the last also 19 years. I worked for Yahoo, and one of the fallout from the Walnut Creek .com explosion, they were looking for a host for the FreeBSD cluster, and they asked us, and we accepted, and we hosted it at Yahoo. And I kind of fell into the admin role for a while, helped out by a number of other people there, Sean, Heron, and former Yahoos. Particularly Paul Saab, who helped get it off the ground. But yeah, so that cluster work, FreeBSD core developer, general troublemaker, I think I sort of like to describe myself.
Mm-hmm.
Yes,
There's a lot of those around, but they get stuff done.
Yeah, I was to
That's a good
say,
thing.
you know,
I've seen a lot of things, what we've tried, what doesn't work, and usually when somebody's silly enough to ask, why is it like this? The problem is I usually know why.
yeah, yes, you're the
Cool.
keeper of the tribal knowledge.
One of.
So-
Yes.
So give us a little background on the FreeBSD cluster. You know, what kind of hardware, what kind of servers, where are they actually located?
Originally, it was a hodgepodge of servers that we sort of inherited, hand-me-downs, donations. Once it got moved into a data center where appearances started to matter, we had to have to rein that in a little bit, and it got replaced with sort of more production kind of servers that you'd tend to recognize. A lot of HP, Dell, Rackable, Supermicro machines. Most of it's 1U, there's some 2U stuff, but in general, it's pretty run-of-the-mill. So HP, DL160, whatever, Dell equivalents, Supermicro equivalents, NetApp in the middle of it. We have some small Atom systems for low CPU intensive stuff that we don't want to waste a lot of power on, but they do functions that are kind of convenient to keep separate, like Kerberos server and things like that. You just don't want them anywhere near anything else if you can help it.
Right.
And so it's kind of a waste to burn a whole server with 200 gigs of RAM or whatever on
Right,
it.
and just running Kerberos.
Yeah. They're generally, we run ZFS just about everywhere we can help it, mostly because it's mostly administration convenience.
I guess that was kind of the point behind ZFS, was to make the sysadmin job easier, and it does a really good job of that.
You know, we had these really scary machines once upon a time, like hub.freebsd.org's been around since 97 or so. It's been continuously upgraded and tweaked and massaged and resuscitated, and it's exploded and hit me in the face with little flying pieces of plastic from the voltage regulator. I think all sorts of fun like that. But that machine has been around since almost as long as Freefall itself, and we just recently transitioned it over to a full ZFS system, and just being able to do things like a snapshot before you risk destroying everything is an incredible liberator. It's not as fast, but you know, it's having the safety net is priceless.
Yeah. Cool. Well, can you give us an idea of the scale? Just approximately how many servers are under the responsibility of the cluster admin?
So right now, there's about 130 over 6 geographic locations around the world that are directly tied into the FreeBSD.org cluster itself, and they do everything from mirrors through everything. We have a couple of satellite things, like we have one in Santax in Canada. We have a fairly extensive set of third-party mirrors. Let's see what else. 130 odd machines. There's a lot of microservers in there that a machine exists, but it has things on it that we consider sensitive enough that it's worth keeping a small low-end server somewhere out of harm's way, that just in case something goes wrong, it's standalone. And we kind of fell into that after the security incident in 2012 to sort of keep things petitioned more than we used to.
Sure.
There's a lot of jails. There's 110, 120 something jails spread across those as well. So discrete instances multiply fairly quickly once you start doing that.
So I guess who else makes up the cluster admin team?
So the main troublemakers, there's myself, there's Glenn Barber, who's employed by the foundation, and he spends about 120% of his time doing release engineering, about another 120% of his time doing FreeBSD cluster work, about another 120% of his time being generally angry at people for doing stupid things.
Yeah. And somewhere in there he also finds time to be on DocEng as well.
I don't know how he does it.
Either.
I really don't know how.
Wow.
Yeah.
So the main troublemakers, there's Glenn and myself. Sean Bruno does a number of things with sort of bringing up new package builders, doing a lot of work on things like ARM packages. We have Simon and Bjorn. We have a couple of people who things are on fire and they jump in and they see things, they're exposed to things that they've never come across before, and they just figure it out and fix it. So that would be people like Ryan Steinmetz, for example. He basically will see a problem and will just dive in and fix it.
Right.
Oh, that's cool.
Yeah. How does one go about ending up on that team? Is it more you kind of get drafted, or?
It's kind of happened by accident more than by planning.
Yeah.
So we have David Wolfskill from, he's officially part of Postmaster, but he is kind of always there. So he needs the mail systems touch a lot of different sort of infrastructure and things like that. So he part of doing his job is kind of needed to do that, but he doesn't deal with that day-to-day running, but he's there. It's usually when there's tasks have arrived that parallelize well, that we don't have enough hands, then we start looking for people.
Right.
And we've inherited a mess and we've been trying to fix it up. And the problem with that is a lot of that's implicitly single-threaded, and so more hands don't necessarily help.
Right.
Sometimes when it's fighting fires, yes, you need as many hands as you can get. But when things are lockstepped on this change leads to this change, which leads to this change, which leads to this change, it's difficult to get more people without a lot of toe stomping involved. The kitchen's kind of small for some of it.
Sure. So do you guys use any sort of automation tools like Puppet or SaltStack to help with that?
Next month.
Next month. Okay.
It used to all be done by hand. Every single machine was unique. Every single jail was unique. It was
messy.
Glenn thought I was crazy. He was probably right. And he's been passive-aggressively sort of trolling me into fixing that. And so this month we've finally got onto a single binary build. Last month we got a single binary build of packages. This month we got a single binary build of the base OS. And everything is running the same thing as of this morning. It's about 90% complete.
So you're running the same checkout of head on every machine?
Yes, we do. We used to check out head on every single machine, but these days, as of the last few weeks, we've been doing it in a build jail and snapshotting that and doing something kind of like FreeBSD update, but not quite. I was using Etsy update from the base system rather than merge master. We've basically figured out a way of replicating what we get from build world, install world, and port master without actually having to do that on
each machine
200 plus times. That gets old after a while.
Sure.
But
It gets very old after a while.
yes, but you basically run the same revision on every machine rather than staggering them or something. Well, I guess they don't all reboot at the same time, I suppose.
We don't all reboot them at the same time. We do daily builds and sort of do advanced testing, and once we settle on something, then we do a bulk update. Right. Things like the firewall machines we run in pairs with failovers, right. And it's something that we'd actually like to do but aren't really doing enough of yet, and that's leaving one blaze the trail for the other one, right. Just for things like when you lose both firewalls at the same time because of a panic, it's kind of embarrassing. Yes. So we don't like to think about that. And part of the plan was that one was going to lead the other one, and we were going to alternate updates, but we haven't actually done that yet.
Right, but that's the plan anyway.
Yeah, it's definitely the plan, and being able to sort of alternate and sort of be able to keep a better lid on the upgrades and refresh cycle is kind of important first. But there's another important gotcha here, is that this runs developer code rather than release code, and so when you have a release cycle that happens every new major release every couple of years and security patches every so often, the upgrade cycles is relatively manageable. But what we're doing is we're using this as part of the development cycle, and we're running everything in anger that we possibly can. Yeah. And so that's why we were running build world, install world for so long, because it was tracking head, and that brings all sorts of interesting challenges to be able to sort of keep up with that. And that's why we don't use off-the-shelf tools for some of the things that we could otherwise do if we were running release builds.
Right, because everything's running ahead, and so is there like a set cycle for how often you upgrade each machine to like the latest head, or?
We've generally tried to do it roughly every month. Yeah. So first weekend of each month is the schedule that we sort of had to sort of try and keep surprises down. That's been a little disrupted over the last few weeks as we've been trying to sort of do a better way to do it so that we can automate a lot more of this. And one of the things that we do want to do, because you mentioned the automation before, is once we have matched package. So if you have release builds, everything all matches. You don't have binary version mismatches or shared library mismatches. But once you have a coordinated base system and a coordinated package set, then it's a lot less risky to be able to do things like automated package upgrades and automated machine upgrades when you know that everything's going to fit together and work. Right. And that's something that we want to do a lot more of. We just haven't quite got there yet. I haven't felt safe enough to do it yet. Glenn's been ready to go for 12 months, but I haven't. I've been saying no and holding him off for a while.
Cool. So I guess one of the reasons that you run head is to take advantage of the latest FreeBSD features, as well as to find the problems with those before you inflict them on others. But what features of FreeBSD does the cluster take advantage of?
One of the first things that we used, one of the very first poster child cases for running head was back when 10 current was head, was the PF work and the new CARP and the new PF, and I say new, but I mean the multi-threaded PF.
Right. Sure.
So we wanted to be able to run that with VPNs and IPsec, and that was a specific set of things that forced the issue for why we ran head on the first round of machines. And then we discovered that head was kind of going off into the weeds, and so we forced the issue. We run head in order to force people to think about the fact that this is going to be running the SVN servers, this is going to be running the mail servers, this is going to be running web servers. Soon, really think twice before you start dumping garbage in there.
Yeah,
sure. It doesn't always work. We find things.
Yeah, but I think in general it has helped with keeping head more in a working state more often.
Well, better you guys find it than somebody who doesn't know how to diagnose it and talk to people to get it fixed.
There's a difference between doing this just simply you only live once, kind of like let's do this kind of thing, versus being able to being confident that when it blows up, you can do something about it. And if we couldn't deal with things on fire and things panicking and exploding, then this wouldn't even be a viable sort of tactic.
Right.
But we have the brain cycles to deal with it, and since we can get away with it, we're doing it.
Right. And with using things like CARP, you can kind of design it in such a way that it's not a critical problem if that machine panics, because it's not going to interrupt that much.
We in the aftermath of the security incident, we sort of got to think a lot about how things like the privilege flow works and how stuff's replicated, and we designed a lot of things around like pull versus push, and machines can't reach in and touch stuff that they're not supposed to. But yeah, we've designed a lot of resilience into it. However, there's still plenty of things that can go wrong that can be quite visible.
But I guess
So what kind of,
we just mentioned features, but I guess you use jails, IPv6, CARP, PF, ZFS, Beehive. Is there anything else you can think of that yet?
That about covers it. Extensive use of ZFS, extensive use of jails. We're using less CARP than we could. We're using GeoDNS, dynamic DNS.
Yep.
A lot of the protocols have failover built into them. The application, like package, for example, has built-in fallbacks, so it's less critical to have a guaranteed that it must be working when the application itself can deal with getting from other sources. Web stuff, there's too many single points of failure in there still. Yeah, that's all jailed and petitioned, and not as much Beehive as we could use, but it's being used in anger. That's something that Sean helped get set up, and I have got very much hands off with that. I have enough to deal with already.
Sure.
Yeah.
So it runs the Jenkins things, for example.
Right. Yeah, we talked to Craig Rodriguez about some of that as well.
So kind of changing gears a little bit, how about security officer? What kind of access does a security officer have, and what does he and the rest of the team do in regards to the infrastructure?
For the most part, separate universes. However, they have a small little bastion island of machines that they build FreeBSD update releases on, and in theory, I could walk into the machine room where they physically are, but for the most part, they're kind of separate universes. We get heads-up warnings when things come through, that security issues come through that affect the cluster. We're generally pretty good about sort of keeping that stuff separate. We don't get to hear about things that we don't need to know about any sooner than anyone else does.
Sure.
It's generally designed around resilience to make sure that I don't want to tempt fate here.
Yeah.
We've tried to design it so I was going to say if something bad happens, but when something bad happens next time, we'll at least know what damage was done and can contain it, hopefully before things get too far out of control.
Right.
For example, we're using auditing, and all the audit records are collected in sealed boxes and all that kind of fun things. That's one of the things that wasn't mentioned on that list of features that we
Audit
use.
D and Audit Disty.
We keep system call logs, traces, all that kind of stuff, and they go into sort of a pound only sort of data stores. It's not something that we talk a lot about, but that's there so that when something goes wrong next time, we'll at least know what's been exposed and what we have to wipe.
Right. Cool. So I guess you already said that almost all the production machines run current. And have you had much experience upgrading machines between major versions as you transition to running head on everything? Or did you mostly just wipe and recreate it?
Most machines we've kind of transitioned away from machines that have too much sort of inertia or investment in sort of in the setup. We like to be able to recreate them on demand.
Right.
So we've done more of that where we've created a new one as a proof of concept that we or somebody else in the team can actually do it, and it's not sort of all doesn't have too much knowledge that's embedded somewhere in the back of Peter's dark and twisted memory somewhere for how to make it work.
Right.
So,
Sure.
so we've done more of reinstalling rather than upgrading, but we certainly have done a lot of upgrades. Like Hub began life as a 3.0 current on i386, and it's currently running AMD 64 9X AMD 64 head, or not head, but yeah, so it's still got binaries that date all the way back to the beginning of time.
Wow.
Yeah.
As Glenn says, it needs to have an accident.
Yes, he does say that. Well, yeah, I've had pretty good experience with upgrading. I had a box that started life as like 6.1 and is upgraded all the way to 9.3 remotely with only SSH access, and I've managed to not
Yeah.
brick it yet.
No, it didn't break it. All right, well that's yeah, makeup. So I just had a quick look on the other screen. So about 100 11x, about 15 10x, about 15 9x, and 2 8x machines.
Cool.
Well, that's plenty to keep updated. And you kind of touched on this earlier, but how do you actually keep all those boxes updated?
So that's an interesting story. I'm glad you asked.
Oh.
Hey, story time.
Once upon a time, it was open up 130 plus SSH windows and type make world on every single one and install world on every single one and port master on every single one. And that was kind of single threaded. So, you know, when things work the same, it scales reasonably well, but it just takes time, and it's drudge work. It's not a lot of fun. I used I used to tell Glenn, well, it allows me to gather my thoughts and find all the things that shouldn't be different on the machines when I stumble across them. But these days, it's as of this round, we basically do a new build and we run a command, one single command on each machine that does everything: refresh, kernel, boot blocks, file system updates, equivalent of a merge master, wherever that's possible to automate, it does it. Package upgrades, all of that stuff. It's almost down to one command at this point. And with something like Glenn's favorite is CF Engine, just basically because it's got no Ruby in it. It's plausible that we could start going in that direction in the future. We're not quite there yet because there's redundancy dependencies. Like you can't take down all of the name servers at the same time,
Right.
for example. That's bad. But yeah, I spent a lot of time on this particular cycle transitioning to a common build, and most of that was reading what's still outstanding, what's different, what we're going to run into trouble with, and making sure that there's no surprises. And invariably the surprises, but for the most part, it's this last round, it was still SSH 130 plus windows open, and that breaks a Mac, by the way. They only have 128 sudo TDYs.
Oh.
Oh.
I was going to say, even on my Windows machine here, I've had 160 putty windows going before. Because we did things pretty much the same way up until recently when we managed to get it down to 4 separate package sets.
Yeah. We have multiple package set capabilities, but so far we tried very hard not to have to use it, and so far we've managed to pull it off.
Right. Well, we probably could use the multiple repo support a little better. Like there are some cases where the only difference between this set and that set is like 3 packages config options. You know, this one we have a heavy Nginx for the web server and a light one for the edge server. And we could probably commonize most of the packages, but we just do the whole set separate because it doesn't take long to compile with 48 cores.
Yeah, I think our builds take a couple of hours. We build 11, 10, 9, almost 8. We could, but we're not using a. So I'll back up a little. The Powder Keg Builder still uses build world jails for the package sets, and the way that we did our binary builds and binary install is it looks to the outside like a real FreeBSD release, and things that know how to deal with that generally we can fall into working, and PowderKeg works sufficiently well that we can switch to binary releases. So we'll probably do 8x as well. So that's 8, 9, 10, 11 on 10 and 11 on i386, and that takes a couple of hours to do a full set run. So it's well within the bounds of doing a daily sanity check and a daily refresh. It's incredibly liberating not have to do that 200 times.
Yeah.
Sure.
So I guess have there been any mistakes or lessons that the team has learned that's been important going forward? Any good stories you can tell us?
LDAP. LDAP. So once upon a time, everything worked with Yellow Pages or NIS. Mm-hmm. And everyone said, well, clearly LDAP is the correct solution. We should replace everything with LDAP. And we learned very, very quickly that when you have an inverted network and you can't control the connectivity, and we have machines all over the planet, and it's on donated hardware and donated bandwidth, when things like LDAP break, all sorts of bad things happen. And so we learned very early on, wherever possible, the machines run standalone and independent and self-contained if we can possibly do it. So the common name servers die, they can look them, they will struggle, but they can do name resolution. So if we break all the core name servers at once, it's theoretically not game over for the cluster. There's no. That was a hard-earned lesson, was to not do that. We still store everything in LDAP, but what we do is we do a periodic ROM that exports everything and builds master.password style things and distributes those amongst all the machines, and that's a roughly 10-minute event horizon for that. So an update on LDAP is live on every machine within 10 minutes. Probably switch to using something like CF Engine at some point in the future, but at the moment that's homegrown and kind of hairy. Mm-hmm. We've learnt not to mess with things like mail subsystems on a large scale. It's a very good way to generate thousands and thousands and thousands of error messages. Or we've tried to switch from send mail to other things several times, and every single time that's ended in disaster. Mm-hmm. We've learnt the hard way about getting creative with early ZFS. We've learnt the hard way about deferring security-sensitive maintenance, and that led to the September 2012 security incident. There was work in progress. We knew better, and unfortunately, we didn't quite have the time that we thought we did.
Yeah.
Mm-hmm. We've learnt that you absolutely cannot trust hardware RAID controllers. Having ZFS being able to check for drive and actually verify the contents of them has been enlightening. We've seen a number of high-profile RAID controller manufacturers where the contents have just changed for no apparent reason. So once everything's checksummed, that's a little disturbing to discover.
Yeah.
Why that turned out to be a good thing. I think it comes down to cache memory on the RAID controllers, but I really don't know what's going on there. But you can read something and then get something completely different back, and then when you read it again, it's back to the original data. So it's a little disturbing. So yeah. we don't use RAID controllers. We specifically spec machines without them if we possibly can. And if we're forced to have a RAID controller, we generally configure it as JBODs if we can possibly help it. That saved our skin a number of times now. Yep.
Well, you kind of touched on it though, but can you tell us what happened with the developer's SSH key in the infamous 2012 incident?
So one of the interesting things about the FreeBSD cluster is it's an inverted network. If you look at a classic sort of corporate style Bastion network, you have all the good guys on the inside, and you have a Bastion firewall, and all of the riffraff are on the outside, and nobody gets in unless you get a signature in blood from your certificates or whatever. All of our stuff is inside out, where all of the good guys are on the outside with the bad guys, and so they need to be able to reach in to do all their work. And that means people are SSHing from home, and when SSH agents on home machines get compromised or through a jump host or a university network, in this particular case, it was a university network involved, then there's not much that can sort of stop propagation from there on. Everything was on /home, a shared NFS home directory. All the authorized keys were writable by the user. So once you got a foot in the door, you had access to everything. And that was one of the things that we learned to change. One of the things we changed from that is we've designed it so that loss of an SSH key shouldn't be a big deal. So yes, an SSH key will get a stolen developer SSH key will get you to be able to commit, but you can't actually get into the SVN repository. The only way you can make a change involves something that will generate a visible commit message. So fingers crossed. Fingers crossed. We've sort of thought pretty hard about trying to make sure that when it happens, it's not going to be too bad, and we'll be able to sort of nip it in the bud next time. The actual origin of patient zero, we have a short list of what probably happened, but they basically got sufficient access to the point that they could use automated tools that scraped things like netstat to see where people were connecting from. They were then gathering a library of SSH keys and SSH agents. They were connecting back to people's home machines to see what those home machines could connect to. The level of automation and sophistication of that was pretty scary, and we were lucky it was caught quickly enough. Incidentally, that was David Wolfskill who spotted that one. So he reads all of his logs. So yeah, he saw somebody SSHing as DHW back to his firewall machine, and it turned out that the reason why he noticed that was because he never SSHs to his firewall machine, and he saw a login fail as DHW on his gateway machine, and that was when we started tracking back, and we found the scraper because it was his NAT box, so that's where the NAT connection appeared to come from.
Right.
So when their tool scraped all the netstat connections to find out where, and they were testing keys to see what worked, and build a sort of a mesh network of knowledge of where everything worked, they ended up sort of stepping on that particular landmine. So yeah, that was a lot of pain and suffering, but we learned to be a lot more paranoid in the process.
So I guess, yeah, you've just described kind of how that inside out network works, but is there anything else that you do to try to separate the good guys from the bad guys when everybody's kind of coming from the same domain?
So we make extensive use of VLANs. We run PF firewalls between all the VLANs. Machines from one VLAN have essentially no more access to machines in another VLAN that somebody out there on the internet has. Slightly more, like they can query the cluster resolvers and Kerberos servers and things like that. But by default, a machine can't just reach over and scan another or anything like that. They just don't have any more access that you could do from your machine at home.
Right, so just limiting the trust of machines in the cluster have for other machines in the cluster.
They don't trust each other. They don't trust each other. They pull rather than push. Machine X, nowhere that I know of one machine in the cluster can SSH to another.
Okay. So
it's all developer driven and pull based rather than push based. So we publish through HTTP on an SUB server, which things will pull and check signing keys and things like that, rather than something pushing over SSH over an rsync or something.
Right.
So the theory is that when something goes wrong, it's not going to be an automatic chain reaction. I'm sure we'll have missed something, but that's where all the audit logs come from, to find out what actually happened and make sure that it's contained and what's exposed.
Mm-hmm. So what would you say is the oldest or strangest box that's still running in the infrastructure?
Oldest box, I've mentioned it before, is Hub. It's not its original hardware, but it's been continuously spinning. The OS has been spinning disks since about 1997 or so, and it's been continuously upgraded ever since then. So 3.0 current. Yeah, that's a special one.
Mm-hmm.
It's, for example, it currently does. If you use the somewhat broken search system on the main website, that still gets run on Hub for reasons that I'm going to end up in tears if I start to talk about. We have, yeah, Hub, oldest and strangest by far. We have some Itaniums. We have PowerPCs. I don't really sort of call the PowerPC machines old or strange. They're just kind of old. With some UltraSpark gear. We have an increasingly large collection of hardware that doesn't really exist, that's running QEMU and other bizarre things like that. The ARM package builds, for example, are running on an interesting abomination that Sean is learning from. You should talk to him about that.
Yeah, I just told him he's been volunteered.
We were just talking about building ARM packages, and that's when Alan's like, "Yep, we need to talk to Sean."
Yep.
There's some really special things that happen there.
Yeah, I saw.
So we have hardware. So if you SSH to it and log into it, it's running ARM binaries, and it looks like it's running ARM binaries, and you do a but it's not. Oh. It's a figment of our imagination. It's running a QEMU helper inside the kernel so that it can run autoconf scripts and stuff. It's really, I think that's probably one of the most bizarre arrangements that we have. So Hub is oldest and strangest, but the ARM package building stuff, I think, is right up there with it.
That's an AMD 64 machine pretending to be ARM?
Yes. And compiling ARM binaries and running ARM binaries.
Right. Doing a very good job of pretending.
It's very scary. That's one of the things that, whoa, hold on there, buddy. How about why just keep away from that?
So is there any other future plans for the infrastructure, things that you're considering doing or are planning?
So there's a lot of this has there's a lot of inertia in things have always been done the way that they're done because that's the way that they've been done, and we've been doing a lot of work digging things out, understanding what we've inherited and trying to codify it, check stuff into repositories so that we actually have a history of what changed,
right.
Automate deployment of it.
Make it actually replaceable.
Reproducible.
Yeah, reproducible.
Reproducible, because right now, if Hub died, we would have to restore it from backups because there's still magic on there that just boggles the mind when we dig into it to find out why something's not working. Yeah, it was an eye opener to discover that we have binaries from 2001 still functioning. Or
ooh.
Yeah. Ooh. Ooh. Yeah. Ooh. That turned up because the port that they originally came from expired, and when we're checking for packages on the machines that weren't existed in the powder keg repository, that turned up, and then we looked further and discovered that actually no, the package was built in 2006, but there's a symlink from the binaries in there to the FreeBSD 4 current binaries, and yeah, needs to have an accident. Not today though. Not today. There's more things to finish today.
Not fish to fry today.
So where we're going is we'd very much like to have this essentially automated, predictable, actually running something still that's worthwhile stress testing for current to make sure things don't get out of hand. That's really important because we have the brain cycles to deal with the fallout. That it's important that somebody does it. I know there's there's individual developers who do it, but doing it on this scale shakes all sorts of interesting things out. And if we can find it so that nobody else has to, then that's even better.
Exactly.
Cool. Okay, well, that's pretty much all the questions we have. Automation.
Yes. All right.
As I say, anything else you want to mention?
And not Ruby.
Not Ruby.
Not Ruby.
Yeah.
Yeah. What do I want to add? It's been a lot. This is a result of a lot of people's effort over the years. A lot of volunteer work. There's been a lot of inherited things where people have had to figure out what was left behind, and so. Although I say Hub needs to have an accident or needs generous application of cleansing flame, it's more of a testament that the long-term binary stability of it is that good that we can actually run things from last millennium and not even know that we're doing it because they just work. Yep. Having said that, it still needs to have an accident.
Yeah.
But yeah, it's built on a lot of work from a lot of people, and it's been an interesting experience. I have learned a lot from it.
Cool. Okay. Well, thank you so much for being on the show with us today, Peter. So we want to mention, of course, the other sponsor on the show this week, which is TarSnap. Of course, that's tarsnap.com/BSD Now. Let them know that we sent you. And of course, if you're doing backups, you need to do backups. Obviously, everyone needs to back up your data if you care about your data at all. But if you're going to be doing offsite backups, shoot, I mean, they need to be encrypted. Do you really want to just take the word for some faceless company on the other side of who knows where in whatever data center that they won't leak your information? No, nobody has access to that. We promise, fingers crossed. So TarSnap gets rid of that insecurity and just uncertainty about doing backups to a remote site because it's all encrypted before it leaves your box. Yep. So,
but it's also compressed and deduplicated as well, which makes a big difference because it's pay as you go. You pay for the byte months of storage and the bytes of bandwidth that you use. Because it does compression and deduplication, it means that when you're doing your daily backups, you're only backing up the stuff that has actually changed or been added. And so that means
saving space and bandwidth.
You can have hundreds of backups, right? So you have not just, the most recent week or whatever, but you can keep a long archive of all each change to your laptop or whatever, and still end up paying less than $10 a month for all of the storage and bandwidth that you use. And that's the best thing about TarSnap is because it's prepaid, you never get a surprise bill.
That's right. That's right. So go to TarSnap, get signed up. I think it takes like $5 to open an account and get started. And if you're not backing up a lot of data, that may last you a while. So you'll want to check into that. Okay, well, let's go right into our feedback and questions for the week. We have 2 to choose from. So we'll start up with Todd here asking about Clang and UFS. He says, hey, I like your site a lot. I wrote to Ken a couple days ago about PCBSD downloads in Lumina. Now I'm writing because I read your article on BSDNow.tv, tutorials the desktop. He noticed that you set your etsy make.conf to use CLang instead of GCC 4.8. He said, I was told that Clang is not as good as GCC since I am learning FreeBSD on an old laptop. Using the ports collection is tough because it takes hours, sometimes days, to compile everything from source. So I have to stick to binaries as much as humanly possible. I say this that I was told GCC is faster. I was wondering if you can confirm, or what are your thoughts on this?
Well,
I don't know. My experience was the
yes,
opposite. That Clang was
but also
faster,
it depends on the version of GCC and what you're compiling with it and how it's optimized. And but in general, if you're using the binaries, those are compiled with Clang on someone else's computer and then shipped to you. So in general, most often you don't have to compile anything, right? The package system will give you binaries of everything, and so then you don't have to care about Clang or GCC or even know what they are.
Yeah, I was going to say, especially if you're on an old laptop, don't put yourself through that misery unless there's something you really need to recompile with a non-default option. Shoot, just run the package repository.
Exactly.
And since you mentioned PCBSD, so say you do have a package that you need some default options changed on. We roll our own repo with a lot of different options. So if you send it in to us, it might be something that's reasonable that we'll switch in our repo too. No promises, but we evaluate that on a case-by-case basis.
Exactly. Because PCBSD is a little more end-user desktop focused than the regular FreeBSD port tree, sometimes different default options make a lot of sense.
Well, my philosophy on the default options is you should have as much enabled as possible, because I'd rather waste a little bit of disk space than put somebody through the pain of having to go compile on their own. Because when you package add, you just want all your features to be there. And maybe features you don't use, okay, so you lost a megabyte. Big whoop. But you saved yourself the trouble of having to check out the ports tree and compile it and then remember, oh, wait, I have a special flag.
All that nonsense.
None of that. It should just have it all right there. So that's what our philosophy is.
And he said the other note he had was he read the OpenBSD desktop article and noticed that you have the ability to turn on soft updates on OpenBSD, and he asked if this is available in FreeBSD. And yes, so soft updates originated on FreeBSD, and actually in FreeBSD 10.1, we'll actually have multi-threaded soft updates as well. The difference is that in UFS2 soft updates, it's not a mount time flag. You set it with tunefs, or when you do newfs, when you're creating the partition or the file system, you can set the flag then to enable it. And if you change your mind before and after, you can do tunefs to reconfigure the file system to enable or disable the flag.
Nice. Cool. Hope we answered your questions there. So next up is Brandon. He's asking about jail ports. He says, hello again. I've set up my server with 8 jails or so, and I've been trying to figure out how to get an email when there are out-of-date applications installed in a jail. He said, I currently have jail audit installed, but it seems like package version -v capital IL would serve that purpose on the host, but I'm not sure. I'm sure this is a common question, but I can't seem to find an answer on Google. The jails are a mix of packages and ports, if that makes a difference. I also use Portmaster for the ports. So how do you do that on yours, Alan?
I don't check the version so much because oftentimes I don't care, but I use package audit, which checks all the installed ports against a list of ones that are known to be vulnerable.
Okay.
So rather than getting an email every time there's a new point release of any app in any of my jails, I get an email every time there's an upgrade that I really need to do instead.
Vulnerability.
Yeah, so for that, package already has support for jails. So when you do package version or package audit or any package command, you can also specify -J and the name or number of a jail, and it'll do it in that jail. So currently I use that to actually install packages into a jail with Puppet.
Sure.
And so you can just use package audit against each jail or whatever. So you can actually use something like the JLS command, which gives you a list of the currently running jails, and then for each line of output in that one, you can grab the jail number and, so for each jail that's running, run package audit -J, whatever, and it'll audit all those jails and combine all the output and put that in a cron tab, and you have an email.
There you go.
And because package is the package database, even stuff you install from ports is included.
Is checked as well.
The package audit and package version will include information about stuff you install from ports as well.
Well, thank you, Brandon, for writing in. So as we close this shortened show this week, we want to mention, of course, that our tutorials can be posted in their entirety at bsdnow.tv. So also send questions, comments, show ideas, topics, or stories you want mentioned on the show to feedback@bsdnow.tv. We would appreciate that.
Especially
And also
if you're someone that we haven't got around to interviewing yet, we'd love for you to get in touch and let us know what you want to be interviewed about and or what you're doing that's interesting.
Get you scheduled right away.
Get some questions written up. We send you the questions ahead of time, so there's no that way you can you'll feel confident that we're not going to come up with a bunch of crazy questions that you're not going to have the answers to off the top of your head or whatever. So there's no reason to be nervous. It's easy.
We're not trying
to trap 50 people have done it
right.
already. It can't be that bad.
That's right. That's right. They'll all tell you this wasn't very painful.
It only takes 20 or 30 minutes, so no problem. And you can watch us live Wednesdays at 2 p.m. Eastern, which is 1800 UTC.
And also, we'll be back next week from EuroBSDCon, hopefully with a huge load of great interviews in tow. So those will be debuting in the upcoming weeks, I'm sure. And we'll be talking all about that, letting you know who we got and who's coming up on the future episodes. So looking forward to that. Man, it's like we're already there, Alan. It's only a few short days away. Very cool. And of course, if you're at Euro, come say hi to us. Come grab us. Let us interview you if you're working on VSD in any capacity. And let us just get that information out of you. There's a lot of people out there who definitely want to hear what's going on.
From experience in the past, I know for a fact that we're going to get a couple emails after the conference like, oh yeah, I saw you at EuroBSDCon, but I didn't come up and say hi because I'm like, well, why not?
Yeah. Come on. Let's just do this. It's real. Again, if you've done interviews with BSD Talk before, it's just casual.
Yes. We just sit you down, point a microphone at you, and ask you silly questions.
Yeah, it'll be fun.
It's like, what was your first one?
Excellent. Okay. Yeah, right. Yeah, give us your war stories. I mean, heck, Sysmin war stories are fun. So we enjoy those. So, okay, well, cool. We'll be back same time next week, guys, and hope to see you then.